Hello folks, so in this video I want to talk about how we can solve and graph single variable inequalities. And it should go actually pretty fast because generally speaking, most of the rules that follow solving single variable equations also applies to solving inequalities. And so let's throw out an example here. So the example we'll try to solve and then graph is something like this. So we'll say 3x, we'll say plus 7 is less than 6. Suppose. Okay, so the way I like to draw this is, or visualize this, is I'll draw a scale. So I'm going to do this. So here's my little scale. Let's make it a little smaller here. And so if 6 is greater than 3x plus 7, or in other words 3x plus 7 is less than 6, I like to think of it as whatever's on the left side of the scale weighs less than the right side. And so that would mean that the right side is going downward like so. And we have a little like plate here that's holding everything up. So on this side, on the left side, we have 3x plus 7. And then we have on the right side, right here, we have 6. So maybe that represents 3x plus 7 pounds. And then on the right side, that's 6 pounds. Okay, so at the end of the day, we want to find all the x values that make this work. So just like with an equation, we want to isolate x, or get x by itself. What we would do if it was an equation is we would simply subtract 7 from both sides. And that's okay because if the scales are even, well, if I take 7 pounds off of both sides, well, since you're losing the same amount on both sides, it would still stay even. That same logic can be applied here, even when the scales are tipped. So if the one side is heavier, if I take 7 pounds away from both of them, well, that same side is still going to be heavier. And so that should make sense to do, and it should be therefore algebraically legal or okay to do. So what I'm going to do is I'm going to remove 7 pounds on both sides. What I'm doing effectively is just doing this, just like you would with a regular equation. Okay, so what's left over then? Well, the thing that's going to be left over is if I repeat the scale here, I'll draw a little bit smaller, but this side will still be heavier than this side. And so now on the left side, we have simply 3x. Let's draw it right here. 3x plus 0. And then we'll have 7 minus 6 is negative 1. So really, we've turned that first inequality into now 3x is less than negative 1. And ignore the fact that's negative pounds. I suppose I didn't think about that in this example. But the analogy still holds. Now again, we have the scales tipped the same way that they were before. And now the question is, how do I get x alone when it's being multiplied by 3? Well, just like an equation, you would divide by 3. And so does that work here? Well, okay, so let's think about an equation. If they're the same weight, the scales are even, we divide both sides by 3, so you're taking a third of this weight and a third of this weight. Are they also going to be the same? Well, if they start off the same, then once you divide both of them by 3, they should still be the same. Now, change it so that one side is actually heavier. If this side is heavier than this one, and you take a third of them, well, a third of this is still going to be heavier than a third of this. And so that inequality is still true. This side will still be heavier than this one. And so that should be okay to do. What we're going to do then is we're going to divide the left side by 3 and divide the right side by 3. And this will change it now to this. So I'm going to go over here now. And we end up with our final inequality that we can actually graph. We'll end up with x is less than negative 1/3. And then that will look like this. So this would be x here on the left side. Once again, I guess I could say that, draw that in there. Negative 1/3. Go draw that in there. Okay. So hopefully the steps there should make sense. And so for the most part, and I'm going to really emphasize that, for the most part, solving inequalities, I'm just going to abbreviate that inequalities algebraically is nearly identical to solving equations. Solving equations. Okay. Again, in the next video, we'll talk about why is it not exactly the same, and Some of you might already be aware of that, but I won't approach that in this video. So for the most part, solving these equations algebraically, inequalities, is just like solving equations. Last thing here is that we also want to graph them, and so I'll do that over here. Let's draw a graph. So since this is only one variable, it's just x, it's not x and y. We just need one dimension, so usually we draw it horizontally. Although I suppose you could do it vertically if you wanted to. And so the important thing here, the only important point really, is -1/3. And so if you want, you could draw in 0, and that's fine too. I'll draw in -1/3 right here. Okay, so it helps me to kind of plot some points and just see if they actually work or not. So I'll draw in -1 here, -2, and then I'll put in 1 and 2. Not to scale, of course. So let's see, if I check x equals 1, is that going to work? Well, no, because right here, 1 is not less than -1/3. So of course that wouldn't be an answer, so we shouldn't put that there. Okay, this one is, right? So -1 is less than -1/3. It's more negative, it's more to the right, so that is a solution. And likewise, -2 is also less than -1/3, and that should be, so that is also a solution. And likewise, we would keep going on and on and on. And so we think, well, how do I graph points? How do I represent all these points without drawing all the dots? Well, just like when you're drawing a line with two variables, you connect all the dots to say all those points are part of the line. And so we're going to do the same thing here. We just simply draw a line going all the way through to imply that it goes all the way, because there's infinitely many solutions that are less than this number. We just represent that with an arrow saying all these numbers on that side. Now, of course, there are other numbers because we forgot about these folks here. What about these guys? Well, right here, so -1/3 is, again, that's -0.3 repeating. So at this point, we have all of these points almost. So remember, we have -0.4, that works. -0.34, that works. -0.334, that works. But let's think about this. Does -1/3 itself work? Is that actually a solution? Well, again, we check by plugging it in. So -1/3, we compare that to, well, -1/3. To be on this graph, you need to be less than. And is that true? Well, no, because the number is not smaller than itself, it's equal to itself. And so how do we represent, we can get super duper duper close to -1/3, but we can't actually be 1/3. This is where, you might have seen this before, and I think I've thrown this out when we're talking about domain and range. We represent that with an open point, so an open dot there. This means, again, you can plug in negative, 1/3 minus a little bit, and then get closer and closer and closer to it. But the answer itself, that value itself, -1/3, is not actually part of the solution. If we had or equal to, x less than or equal to -1/3, then yeah, we could fill in that dot to say, yeah, -1/3 is one of the solutions. That's not the case in this one though, so that's why we're going to leave it with an open circle. Okay, hopefully that helps. And again, stay tuned for the next video where we'll talk about why this is not 100% true. Alrighty, thanks for watching.